So to give you an overview of the Markov chain model, this is a method to model a system. Okay, and how we model the system is basically we model the system as a sequence of states. Okay, so state is nothing but a position in which the system is in at a particular point in time. Okay, so let us say the system is in state S1 at time t1. Okay, and it will go to a state S2 at time t2. Okay, so that is what we call it as the state transition. So movement from one state to another with a specific probability. Okay, so what the Markov chain basically does is it enables you to predict at a particular point in time what state the system is going to be in. Okay, so so when I first came across this concept of Markov chain, I came across this concept in a supply chain context. So within supply chain, it was specifically an inventory sort of a scenario where we were saying, if today I have n number of items in my warehouse, what will be the number of items that I will have tomorrow? Given that there is a certain probability involved, I will sell something, and so based on this probabilistic occurrence, my inventory level will reduce tomorrow. So what will be the reduced level of inventory? So today's inventory level is one state. What would be tomorrow's inventory level? So that is what we call as a Markov chain, where today is the first state, tomorrow is the second state, and these two states are linked by a probability. So since these multiple states are connected, they basically form a chain, and that is why this model is called as the Markov chain model. Now this transition between the states is dependent or conditional. So what do I mean? That is where the probability factor is involved. So given that I am in the state S1 today, there is a probability, or you can say that there is an X% chance that I will go to a state S2 tomorrow. So that is what you say, it's a dependent or conditional. And this Markov chain is also called as the short-term memory model. So why do we call it that? It is because the probability of reaching one state depends only on the previous state. So for example, let us say this particular circle is S1, this circle is S2, right? So before S1, assume that there is one more state S0. Okay, so the probability of going from S1 to S2 only depends on this S1. It does not depend on this S0. So that probability depends only on the immediately preceding state and nothing further beyond that. So that is why we call this as the short-term memory model. So basically, if you see, Markov chain is a system involving different states and the probabilities linking those states, and we use this Markov chain model to predict what would the future state look like based on the probability. So that is the basic definition of the Markov chain model. Any questions here?
Sai, I can see different type of lines connecting three. So does like each line trying to convey something, does it have any meaning or?
No, this is just a schematic representation. I put it just to help me explain to you better how that states and the linkages between states work. There is nothing significant in this diagram.
Okay. Coming to the one more thing, so you told like based on like previous one state or 1 year, right, we will consider the future. So is there any constraint or like why 1 year? Generally people go for 3 or 4 years and do some machine learning model to predict the future or something. So here we are.
The way the Markov chain works is, so it need not necessarily be a year. Okay, so for example, in one of the other applications that I have, I will be talking about how a user goes from one website to another website. So it need not be necessarily a year, but the way the Markov chain model works is it takes only the preceding state. So in fact, there are other models which take into account the states beyond that immediately preceding state. But the way Markov chain works is, so basically you can think of it as a formula. Okay. So this formula works by taking only the immediately preceding state. It doesn't consider anything else.
Okay, understood.
Okay. Any other questions? Okay, let me move to the next slide. So this Markov chain process is what we call as the stochastic process. Okay. So basically, a stochastic process, if you see, it defines the evolution of a random phenomenon over time. Okay, so what does that mean? We will have observations over time, and the outcome is a random variable. Okay, and this also takes different functional inputs at different times. And typically, this Markov chain model is modeled as in the matrix format. So you will have a starting state, and then you will have a destination state or an ending state. And in this matrix, you will basically put the probabilities of transitioning from one state to another. So that's what they say here. The element represents the probability of transition from state 2 to state 1. So the probability of going from state 2 now to state 1 tomorrow is Q. In fact, in one of the previous KKSS sessions, I was talking about one of the projects that I had done, where it was a forecasting project, and I was forecasting the demand for spare parts. I had classified spare parts based on their demand, and I essentially calculated the probability that the part will move from one particular bucket to another bucket. So that is one example of the Markov chain model. So how does this Markov chain model apply in a prediction-based scenario? So on the left side you have the concept, and the right side I will put the application corresponding to that particular concept. Okay. So the concept, if you see, basically we ask the question of how does the system evolve over time? Okay. Or in other words, in what state is the system going to be in n time steps? Okay. So as an example, just consider a parking lot. Okay, so this is the concept, right? In what state is the system going to be in n time steps? So how do you, when you apply the Markov chain model to this concept, what does that translate to? So it looks something like this. So what is the occupancy rate of the parking lot 3 hours from now? So this n time steps is basically the 3 hours. Okay. So what state? So that state is the occupancy rate. So this is the application of the Markov chain model. And another thing that you can possibly do with the Markov chain model is you can trace possible sequences in the process. So that is to say, when the system goes from state A to state B in n number of steps, what is the likelihood or what is the probability that it follows a specific path P? Okay. So this is the concept. Applying this concept to the same parking lot example, it will translate to something like this. What is the probability that the parking lot will go from 50% occupancy to a 25% occupancy in 5 hours? Same translation, n steps is basically the 5 hours. Okay, state A is 50% occupancy, state B is 25% occupancy. So in the span of 5 hours, what is the probability of transitioning from one state to another? So this is how you apply the Markov chain model in the real time. Any questions on this example or the application? Okay, so now maybe I will just go into a more elaborate or more detailed example. Okay, now typically if you see when you browse through a website, right, or when you try to shop for something, it is not a single step process. So if you're absolutely sure that this is something that you want to buy, then it's pretty straightforward. But let's say you're doing some sort of a window shopping, you're unsure of what to buy, there's lots of options available in the market and so on, right? So in this kind of a scenario, you will have multiple touch points available. Now you just relate the word touch points to what I was talking about for the past couple of weeks. We said that in the typical business to business sales cycle, the prospective customer interacts with the company, and then this interaction occurs over an extended period of time. There are a lot of touch points involved in this interaction. So that is what you see here. So you start, and then people attend a webinar, and some of those people click on the LinkedIn ad, and then they buy the product. Or they could just go see a Google ad, and then they make a phone call, make some inquiries, and then they buy the product. So like this, there could be several steps involved, right? And I was also saying that this sort of a user flow would involve both online as well as offline data. So typically this webinar details how many customers attended what webinars and how many phone calls did people make and so on. So this is an offline data. The rest of the data that we have, basically number of people who clicked on the LinkedIn ad, number of people who clicked on the Google ad and so on. So that is the clickstream data or the online data. So to use or to apply this Markov chain model in the attribution modeling scenario, you would need both this online and offline data. You would need to integrate this data as to what was the flow or the path followed by the users. Okay. So for this, of course, you would need the timestamps, and you would sort the events based on timestamp, and you would arrive at this kind of a user flow or a map. Okay. So this is the first step in the Markov chain modeling in the B2B attribution scenario. This is what is called as the Markov graph. Okay. You can see that the graph has certain percentage values. I'll explain what they are. Now imagine there were 100 prospective customers at the beginning. Now out of these 100 prospective customers, 80 people attended the webinar, and then 50 people clicked on the LinkedIn advertisement, and out of those 50, 30 people finally purchased the product, right? And out of this 100 people, let's say 70 people clicked on the Google ad, and out of the 70, 40 made a phone call to the company, got some details and so on. And then out of this 40, 30 people finally purchased the product. Now, you see these percentage numbers. How we are calculating is basically the number of people in a stage S divided by the number of people in the preceding stage. Okay, so basically for this 80%, it is nothing but this 80 by 100. 63% is nothing but 50 by 80. Now, there is also one more flow where people have attended this webinar and directly purchased the product. So this 37.5 is nothing but this 30 divided by 80. So this is what I meant when I was saying it is a short-term process. So any particular stage is dependent on only the previous stage. So the LinkedIn ad, the probability of going from the webinar to the LinkedIn ad is 63%, which is nothing but this 50 by 80. It does not consider this 100. Okay, so that is why we call this as the short-term memory model. So this is the first step in the application of the Markov chain model. You draw the Markov graph, and then you calculate these probabilities of going from each stage to the other based on all possible user paths that are available in the data. Any questions here until now?
Yeah, Sai. So we are assuming that some people have gone to webinar and also the Google ad. So if they make a purchase, so where we are classifying them, whether they went through webinar or Google ads then?
Yeah, I'll come to that in the subsequent slides. In fact, that is what the entire attribution process is all about. So that involves a few additional steps. I will explain.
Okay.
Any other questions? Okay, let me move on to the next one. So the first stage, like I said, is the probability calculations. So you identify the stages and define the full set of states. So starting state, then the webinar, LinkedIn ad, Google ad, phone call, or conversion or purchase. And then there's also a null state, which I haven't put here. This null basically means, so out of the 50 people, we are saying 30 people purchase the product, right? But what happened to the remaining 20? So that would go to the null state. So just for a mathematical representation, you form this universal set where you also include this null value. And then once you have arrived at this universal set of states, you trace all possible navigational paths, which is to say that you basically draw this map over here, all the user flows. And then you calculate the state transition probabilities for all possible success paths. And then you calculate something called as the total success rate of the Markov graph by adding all probabilities obtained in step 3. Now I'll explain how this works. And so this formula for the transition probability is basically nothing but number of people visiting the stage n divided by number of people visiting stage n minus 1. It is a particular stage divided by the number of people in the immediately preceding stage. So how do you exactly calculate this total probability? What I mentioned in this point number 5, this is how you do it. Okay. So you list down all the successful paths. So if you just go back to this picture here, so this is one success path. So start a webinar, LinkedIn ad, conversion. Another success path is start webinar, conversion. Another success path is start Google ad, phone call and conversion. So you list down all possible success paths from your Markov graph or the Markov map, and then you take a product of all the probabilities involved in that particular path. So for example, if you see the first path here, start, webinar, LinkedIn ad and purchase. So this is nothing but this 80 into 63 into 60 percentage. That is what you have here, which gives you a probability of 30%. And the other success path is start, webinar and purchase, which is 0.8 into 0.375. This one, 0.8 into 0.375. That again gives you a 30% probability. Like this you calculate for the other success path as well. This also gives you 30%. So finally you sum these three values and then you say total success rate of the Markov graph is 90%. Okay. Now where do you go from here? So this is the first stage where you draw the Markov graph and then you calculate these probabilities and then you calculate the total success rate of the entire Markov graph. So after finishing this first stage, you go to stage 2, which is the attribution. Now, Swap, I will come to that point you were mentioning. So we calculate something called as the removal effect. Okay. So what this removal effect basically means is, it is the change in probability of reaching the conversion state from the start state when we remove a particular channel from the graph. Okay. In simpler terms, what this basically means is, let me just come back to this graph here. So we have webinar, we have LinkedIn ad, we have Google ad, we have phone calls, right? So we have these 4 different channels via which customers have come to us, customers have interacted with us. Okay. Now, how much of our revenue should be attributed to each of these 4 channels that we have here? So which takes more credit, which takes less credit, which is responsible for a particular conversion, which is not. Okay. So that is what this attribution is all about, and that is where we use this removal effect. So why do they call it a removal effect? What we do is basically, so imagine we got some $1 million in conversion. If I remove this Google ad from this chain, what would be the value that I would have obtained? So that difference is called as the removal effect, and that difference is attributed to that particular channel which you remove from this graph. So if you remove Google ad, let us say you get a loss of some $20,000, right? So then you basically say that $20,000, this Google ad has been responsible for that $20,000, and thereby you attribute that $20,000 in revenue to this Google ad. So that is what this attribution is all about. Swap, does that answer your question? There's actually a formula to calculate this, but this is the principle.
Yeah.
So let me just go to the.
Say just one question, but in real-time scenarios, the path won't be this much clear.
Yes.
So for that, do we make any assumptions?
We do not make any assumptions as such. Of course, since the pathways would be far more complicated in a more realistic scenario, that is where we go for a more scalable solution. In fact, there is an R package that is available, which if you provide the data in the right format, it will take care of these probabilities automatically, and thereby it will also calculate this removal effect for each and every channel. So here, just for us to easily understand the concept, I came up with a very simple flow. But in reality, like you said, there will be flow will be much more complicated. In fact, there will be hundreds of touch points available. Okay, and the probability calculations will be a lot more intricate, but the concept is basically the same. There are no additional assumptions or anything involved there.
Okay.
So like I said, the removal effect is basically the change in probability of reaching the conversion state from the start state when we remove a particular channel from the graph. Channel is nothing but that Google ad or LinkedIn ad or the phone call or the webinar. Okay. And this removal effect can take values from 0 to the total conversion rate. So I have an Excel sheet where I'm having this calculation. zoom this up a bit. Yeah. So we saw until here where we calculated the total success rate of the Markov graph. Okay. Now let us just take one particular channel as an example. Let us just consider the case of the webinar. Now I need to calculate what is the attribution or the monetary value to be attributed to the webinar. Okay. So we come up with this particular metric, which is what we call as the conversion rate of the model without the webinar. Okay. So how does this 30% come? This is nothing but this particular 30% over here. Okay. So why do we take this value? So out of all the 3 success paths that we have here, only the third one does not involve the webinar. That is what this 30% is all about. Okay? So we exclude the first 2 success paths because they flow via this webinar. So we exclude them and we consider only this one which does not involve the webinar, and that way we consider the conversion rate of the model without the webinar to be 30%. Okay. And then we calculate the removal effect of the webinar using this particular formula, which is nothing but 1 minus this 30% divided by the total success rate. So 1 minus 30% by 90%, which gives you value of 67%. So what is the implication or what is the insight here? So if you remove the webinar from your chain of conversions or from the Markov graph, we could lose 67% of the conversions. Okay. So this is the amount of revenue that you will attribute to the webinar. Okay. So just assume that total value of all successful buyer journeys is $1 million. Okay. Which is to say that people who have attended the webinar, people who have clicked on the LinkedIn ad, people who have clicked on the Google ad, people who have made phone calls. So everybody who has converted via these 4 channels has contributed to a revenue of $1 million. Okay. So when it comes to attribution modeling, what we actually need to do is, how much of this $1 million should I attribute to the webinar? How much of this $1 million should I attribute to the Google ad? Okay. That is what is the purpose of this attribution modeling. And we have calculated in the previous step that the removal effect of the webinar is 67%. Now, like I said, the removal effect is defined as the difference in the value that you obtain when you remove a particular channel from the graph, right? So here we have removed the webinar, and we are saying if we remove the webinar, we could lose 67% of the conversions, which is to say that this webinar is responsible for 67% of this monetary value. So 67% of $1 million is nothing but the $668,000. So out of the total revenue that you have obtained via these 4 channels, 67% is what you attribute to the webinar. So similarly, you can calculate the same attribution value for each of the other 3 channels that you have, and you can individually accurately attribute this $1 million of revenue to each of your 4 different advertising channels. Okay, so now you do this exercise. What comes out at the end of it, you will basically know what ad channels are the most effective, what ad channels work best for you. Okay, so you are saying $668,000 has been attributed to the webinar, right? And let's say the Google ad attribution is coming to $10,000, right? So one way to look at it is, okay, so the majority of my revenue is coming only from the webinar. So do we even need to invest in that Google ad? No need, because that doesn't seem to bring in much of a revenue. Okay, so that is one way of looking at it. The other way of looking at it is, what is the value per person for each of these channels? So the webinar might be $68,000, but there could be hundreds of people who have attended the webinar, right? So the cost per person or the revenue per person could be very low. But on the other hand, the Google ad, few people might have clicked on it, but still it could have generated a lot of revenue. So in that way, if you see, the Google ad could actually have been the more effective channel of the two, right? So this is how I reduce my investment in my least performing channels. So this is one application of the Markov chain model in real time. Typical marketing scenario, attribution modeling scenario. So this is what I had for today's